Hello everyone. All right. So welcome to getting started with Vulkan. Okay. So I think this is basically the Vulkan fundamentals journey. Okay. This program is basically all about how to get started with Vulkan. Okay. Now we I thought to basically start this program back in February, but due to some personal commitments and uh, different engagements, I think I couldn't actually get started, but now I think it's a very good time where we can actually start this program. And since we have actually started with this lecture, you will get actually regular lectures on this, and we will try to cover the basics of this program. All right. Now uh, let's look at basically uh, the fundamental journey. Now today's lecture is basically all about the program overview. So basically it gives you basically 30,000 feet, I mean, overview of the program. So it's basically an eagle's view overview, I would say, of the entire program. Okay, all right. So we will spend our today's lecture. So there will be no code or no examples. Okay, it is more towards basically getting basically a good understanding how this program is basically managed. Okay, and what we will cover in this journey. All right. Now I would say that this program actually I'm calling it as beginners level. So it's a beginners level program. Okay, so it would not be basically incorrect to say that this program is basically built for students or basically for junior developers who wanted to get started with Vulkan. Okay, so there are basically some little expectations, I mean, if you are basically getting started with the beginners level, but the idea is that we will try to understand all the fundamentals of Vulkan if you are basically coming from an OpenGL or you are basically very new to basically graphics programming. But at least we expect that you have basically some kind of experience with 3D graphics language. Okay, now Vulkan, it's basically more towards a modern approach of graphics. Okay, now I would not say modern because it's already been 10 years. Okay, but comparing it to OpenGL, which is basically I mean way back started in 90s. Okay, early 90s. So there is a shift now in today's time. I would say Vulkan, it's a very appropriate language. I would say that this is basically currently being used to replace OpenGL in industry because of multiple reasons. We will learn these reasons in the next basically lecture, but in today's lecture I will try to basically cover more towards the program overview. All right, so I would say that this program is basically, like I mentioned, it's suitable for junior developers or students who are basically getting started with graphics programming, modern graphics programming particularly, and they have basically some experience in OpenGL. So we also expect that you should be having some kind of C++ experience. Okay, and we will be basically doing some programming, not some programming, a lot of programming. Okay, so that was basically an incorrect uh, statement. So we will do basically a lot of programming. Vulkan is verbose. So the overall problem that we are actually trying to fix is that Vulkan is not basically covered in university programs. Maybe not many, some of them definitely, but the thing is that Vulkan is a bit verbose. Okay, if you're coming from OpenGL and you go and wanted to start basically with Vulkan, so that is basically a very big question for basically beginners or junior level developers, that where do I get started with, because Vulkan's approach is very different from the traditional graphics language, whether it's DirectX, okay, 11, 10, 8, 9, or basically OpenGL itself. So I would say that there is basically a learning curve, and that learning curve is what we are trying to fix with this Vulkan fundamental program, which is getting started with Vulkan. All right, now without overwhelming with this complex theory, what I want is basically I'll try to help the community, help the students, help the junior developers to get started and basically learn modern graphics in a very simple way, in probably a way that actually I believe the way actually I try to structure is basically more step by step way. Okay, so I'll try to cover every topic progressively. Okay, I will provide basically some hands-on approach. There will be some documents, presentations and examples, okay, real-time programs. Okay, so you can actually end of the day you can understand the theory, you can look at those examples, you can set up the Vulkan and basically run the code and see how the things gets connected. Now the entire goal, it's not basically to memorize a lot of code. Okay, Vulkan, it's a lot of code, but the idea is basically to understand the ideology of a GPU and how that GPU is basically used in graphics and compute program. Okay, so I would say that Vulkan you can completely used in machine learning. So you do not may need basically OpenCL or CUDA, okay, because Vulkan itself, it provides basically compute capability. So your machine learning, while they do not doing basically any graphics processing, they can still be run using Vulkan because it provides all the parallel parallel program capabilities like OpenCL and CUDA. All right, so I mean, that is basically one of the very strong reason why you should be basically learning Vulkan. Okay, understanding OpenGL, it's good, but getting started into a professional world, I mean, definitely Vulkan is something. It's no brainer. I mean, this is something that the companies expect. I mean, if you are going to any company, any job, okay, so if you are basically a graphics developer, you don't understand basically Vulkan, I mean, I feel that that's not justifiable. Okay, if your major is basically a graphics, or basically you are basically a graphics programmer. Now, so the entire program is basically built so that you can actually learn this modern graphics concepts, okay, in a completely self-paced way, okay, and you will actually become a bit stress free. Okay, so there is no assignments or basically no submission deadlines or pressure, something like that. All right, so the idea is that you try to do with your own comfort, but the promise that actually you need to do to yourself, not to me, is basically you try to go through these lectures, you go to try to go through these slides, and try to understand at your own pace what this modern, I mean, programming is all about. Okay, how it is basically different. So the idea is to get into the shoes of how the modern programming graphics pipelines they are basically laid out, and how you can basically understand a GPU better. In order to understand the GPU better, you need to actually get started with some kind of programming, and this is where I feel that Vulkan, it's very important. It's and basically a very good place. Okay, now I think without going into further, I mean, details, probably it would be good to start basically the Vulkan uh, fundamental journey. Okay, so in today's lecture actually we will try to do basically a program overview. Okay, so what we will try to do is basically uh, so this is basically the, I would say, the entire overview on the first slide that we will try to cover. So there is a dedicated slide for each of these I mean bullet points that actually you can see on the screen. But the idea is basically to understand this entire big journey in 15 to 20 minutes or maybe 30 minutes. Okay, so that it gives you basically a roadmap basically uh, from starting from zero to building basically a real time basically engine system, okay, in Vulkan. All right, so I would say that we will start uh, with very low level from the fundamentals. So we will try to understand the foundations of Vulkan in this program. So we will go through the basics. We will try to see what exactly the Vulkan is. Now when I say what exactly the Vulkan is, there is one complete lecture. Okay, it may be basically 50 minutes or 1 hour, but that is very important from the interview point. Okay, interview point of view, because it actually covers a lot of difference how the modern graphics languages, they are basically different from the basically the traditional languages. Now this is something what actually we will cover in the next lecture, but we will see in this lecture how what is Vulkan, how it compares to other way APIs, and how the overall picture actually fits together. So I would say that this particular lecture would be more towards basically getting the mental model. Okay, so this is the mental model. So we will understand what exactly the mental model of a Vulkan. Okay, now the next thing is basically the setup and debugging. Now what we will do here is basically we will try to set up the environment for Vulkan. So this is where we actually try to start our Vulkan journey in practice. Okay, so we will create basically our very first Vulkan instance. Now the Vulkan instance is not like OpenGL context, I will cover it later, but you will try to understand Vulkan instance is basically a way to connect your application to Vulkan API. Okay, we will look into these things later, but the idea is that once you have created an application with Vulkan, what you can do, it's basically you can create a window. Okay, a window, it's basically where you want it to basically draw the things. Okay, and then we will also look at validation layers. Since you are working with GPU, okay, in OpenGL you don't see basically errors which are very much pretty much defined. Okay, there are set of 5 error codes. Okay, and this is where actually you need to do basically a lot of gymnastic to understand them correctly. Also there are basically errors which are related to driver that you cannot handle it. But Vulkan on the other hand, it provides a validations layer. There are basically tons of error debugging messages, plenty of them available to analyze a problem. Okay, and this is something what we will try to see. Okay, and what we will do, it's basically we will create basically very first program. Okay, which is basically just a connectivity of your Vulkan API to your application program. Probably there would not be something, but you will see your console is speaking. It shows you that you have basically a physical device. Then we will dwell more into it, and during the setup itself we will actually deal with what exactly the physical and logical devices. So this is also we will actually try to understand in this in this lecture, or basically I would say topic. I do not know how many lectures will it be. Okay, small or basically long, I do not know, because I'm also actually creating everything on fly, like you are actually watching these, I mean on fly, I'm also creating these on fly. So I create the examples, I create the hand notes, I create the basically slides, and try to record and publish it. Okay, so uh, this is how actually we are going to I mean carry out this program. Now once you have basically connected with your physical device, which is actually your GPU, in Vulkan, the physical device, it's never used as basically a physical device, but you create uh, a lot of I mean, not a lot of, but if you have basically a physical device, you will create basically a logical device, and you deal with logical device. Okay, so we will actually look more into this one into detail, but the very next thing that actually we will do once we have basically a logical device, we will basically create queues, or basically we will query queues from the GPU. Okay, what are queues? Queues are basically an interface between, I would say, your CPU and GPU. What they do is basically they carry your command buffers, your recorded command buffers from your CPU. You provide some jobs into it, and from those jobs, I mean those jobs are basically which are wrapped into a command buffer. It is basically taken to the GPU, and we have basically a number of queues. Okay, that we will try to understand. Okay, now next what we will try to do is basically we will deal with the display system. Now what is a display system? A display system is where we try to create basically a window and try to render something. So you can understand that this is somewhere we will try to do some kind of rendering. So maybe probably we will, so this is something like a window. So we will create a window, and basically we will paint this window. Okay, now this was basically logical devices. So from a physical GPU we'll get the logical devices, we will create queues, and then we'll have basically we will deal with surfaces. So it's all about window management. Okay, so we have some particular keywords like swap chain and surfaces that we will try to understand here. Now once we have basically set up the window, we have set up the surfaces, the next thing that we will do is we will basically create a render loop, and from this render loop what we will do is basically we will send our command buffers. The command buffers get actually processed into our GPU, and then it will basically output the result. So probably what we can do is basically we can color the window from RGB to see, I mean, if your surface is getting colored properly. Now the next thing that actually we will cover is basically GPU data and memory. Okay, now this is a very important concept, because without GPU data and memory you cannot draw anything. Okay, so probably if you wanted to draw basically a triangle, oh no, if you basically wanted to draw a triangle, now this is where actually you need to basically deal with GPU data and memory, because what you are going to do, you are going to basically deal deeper into the memory types, and based upon those memory types what kind of data that you wanted to store into it. So what we wanted to understand here is we wanted to understand how to manage basically the vertex buffers. We have something called staging buffers, we will understand those, and basically we will also deal with memory types. Now these are certain things that actually you have never seen in OpenGL, because OpenGL does everything behind the scenes driver. So in the next lecture it would be very important for you, so try to we will try to understand, I mean, those basically differences. Right now further we will actually look more into the resources in this particular topic or lecture, which is I mean, I would say uh, basically the resources. So like the resources are coming into the topic like GPU, data, and memory. So Vulkan have actually only two type of resources. One is basically buffers, the another one is textures. Okay, now how to deal with the textures and buffers? We have whole lot of APIs to manage them. How to transfer them? We have different type of ways. Okay, and we have actually various memory allocation strategies. Okay, like VMA. Okay, that I will actually cover later, but this is something what actually we will try to cover. Now the next is basically we will try to dwell into uh, more modular approach. So you may actually understand that by lecture 6 we are capable of drawing a triangle. We understand what exactly the vertex buffers are, how staging buffers work, memory type works, all sort of things. But so far whatever we have did in this example, it's very monolithic. Now this is very monolithic, that means we are just creating one big program and we are trying to render something. But this is not how a good scalable code works. So what we need is basically we need basically a mindset that is basically that is more towards the engineering architecture. Okay, so when I say more towards the engineering architecture, I wanted to emphasize basically how to manage your program into modular design. Okay, and this is something what actually we are basically going to cover next. So into the transition, okay, where we will look more into the architectural aspects. What you are going to do is basically you are basically going to start organizing your code from monolithic to a modular system. Okay, now doing that we will also basically try to learn how to manage basically different type of objects like push constants, uniform buffers. Okay, so that you have basically a scalable design. Okay, next we will actually look more towards basically more into a 3D world where you go from a plain triangle to basically a more 3D approach using MVP pipeline transformation cameras. Okay, now finally I would say that once we have covered this, we would have basically pretty much our graphics pipeline which is capable of doing some 3D graphics rendering into real 3D. We will actually bring some textures into it, and once we actually bring some textures, we have basically, I would say, a good concept of Vulkan now, which is capable of handling buffers, which is capable of handling texture. Now the last step would be basically going into an engine mindset. Okay, so we started with it with very monolithic program, then we try to manage it basically into an engine architecture. But covering, we're still in the beginners level, so it's not that deep level of basically segregation. But the last lecture actually we will cover is basically we'll try to create basically a very thin line where you wanted to create your engine which is completely separable from your game or from your application. So your engine or your framework. Okay, so anything that you're currently making in Vulkan, it's just not meant to draw a triangle, not meant to draw or basically a window with 3D graphics or something like that, but a complete separate framework which is more towards basically like a framework user. So how a real-time engine framework is developed is what we will try to understand. So we will basically change our mindset or our mental model from rendering a simple triangle or basically a fixed graphics to basically a kind of library which is a framework, and from that framework you can actually create your engine, you can create your editor, and using those editors you can actually create games or you can actually create applications. In fact, you can without editor as well. You can just use your engine as a framework and you can create as an application, and that is basically cross platform and run across. So this is something, but actually we will try to cover in basically more or less in this high level journey. Now, so let's get started with basically a little more in detail. So, and now this is basically about trying to understand why we are basically using Vulkan. Well, Vulkan, it's basically more towards the architecture performance. So performance architecture, I would say. So I would say that there is basically a shift in the mindset, okay, where we need basically APIs that is simple enough where we can do more complex job, whereas the older APIs like OpenGL, they were not basically completely suitable for that, and this is the reason actually why we are basically using Vulkan. Now in this first lecture, which is I'm going to cover next in the next lecture, this is something what actually we will try to cover. Now I would say that it would be basically something like getting started with Vulkan. All right, getting started with Vulkan. So what we will try to understand is basically how this API exists. Okay, now when it gets started, how it is different from basically OpenGL view. So what we are going to do is basically we will actually try to understand a mental model. Okay, mental model, and this is basically very important. Okay, now I'll just give you basically a quick timeline. Okay, so let's suppose also this is 2026. Okay, I will say this is 2012. In 2000 around 14, okay, Apple, it released basically Metal. Okay, they don't want it to use basically OpenGL, and from there what we have basically OpenGL and DirectX. Now DirectX was basically completely Microsoft product. Okay, and open source was basically OpenGL. Okay, so throughout the 90s to 2012, okay, OpenGL used basically heavily in industry because it's an open standard. It's not basically bound to a very particular operating system like DirectX, so it was pretty much famous. Now Apple, being Apple, they wanted to do basically things which are very specialized for their hardware, and this is where actually they thought to basically abandon OpenGL and build their own Metal API. Now why I think it was reasonable, because OpenGL, it's an API which is coming from 90s. It's carrying a lot of burden, and day by day the GPUs are changing. Okay, so to adapt with that fast pace, OpenGL is basically a lagging in that. So whereas if Apple just concentrate on Metal and create their small API which is just perfect for their GPU, that idea makes sense. Okay, now when in 2014 Metal got released, okay, then there was basically a tension in the community. The tension was basically OpenGL being open source. It's basically designed for traditional API pipelines, but it's not very much scalable for the modern pipeline requirements. Okay, now this is the same time when they wanted to basically switch to something new, but I would say that I would say, this was something that actually it was basically a worrying factor for the community. So because they also want basically something as an open source, which is just not meant for Apple, and this is where I mean AMD, sorry, AMD have basically one API which is basically very same to metal. Okay, it's called mental, Mantle. So they have this mental API, and they use this mental API, and they propose that sorry, we will basically use this API as an open source, and later on this mental API, it becomes Vulkan API. Okay, so the community came together, which is basically the Kronos. So Kronos is basically a consortium of companies, so everyone actually used the mental, and they actually started to working towards there. So in 2016, I mean Vulkan got officially released. So that was basically Vulkan 1.0 version, and throughout, if you will see, it is almost 10 years now. So Vulkan is basically into existence. So I would say that Vulkan, it's not a new API. It's already there into the market. So it's a very good reason for you to learn. All right. Now this is basically the overall timeline looks like. So being a graphics developer, you should be having these things which pretty much actually seed into your brain. Okay. So maybe actually I'll move to the next slide quickly that we will try to cover. Now, in the next topic, what we will try to do is basically we will set up the Vulkan environment. So I may actually give you the batch files to quickly set up. Okay. At the same time, I expect that you know C++ and you should be familiar with CMake. So I will also pass some of the CMake material to you. Okay, so you can actually try those CMake materials, you can practice it, but most of the programming that actually we are going to do here, we are going to do in using CMake. Okay, so CMake is basically an industry standard, so we will try to use that. So once we have actually set up the Vulkan, what we will do, we will use GLFW. So GLFW will allow us to use basically Vulkan and create window. Why we are using GLFW? Because the program that actually I am building, I mean it is capable of running into Ubuntu, Mac, any Unix flavor and Windows. Okay, so the idea is that it can run anywhere. In fact, you can run it on Android. Okay, there are more information that I will cover into the next lection when we will get started with Vulkan. Now once we have created the window, we will actually create a Vulkan instance. Vulkan instance is not an OpenGL construct, but I would say that Vulkan instance is a lightweight context. Okay, you can still consider that as a construct, I mean, since you are basically into a beginner level. So I think from a layman perspective, just consider this is something like a context, but it is actually not a because OpenGL context comes with along with its own window, its own basically basically buffer management and basically implicit display management. But however, Vulkan, it's not something like that. Okay, so it will allow you your application to connect to your GPU, okay, through a Vulkan instance, and then Vulkan instance, it actually advertises a lot of capabilities of your device, and using those devices, I mean those advertisements, you try to basically configure your device. Maybe you have 3 GPU device, but you wanted to use basically the CUDA or some other basically device. Okay, you wanted to play with the memories, and you wanted to play with various I mean surface management. So a Vulkan instance, I would say it's basically a lightweight connection of your application to your GPU. Okay, and then basically you can do a lot of Lego like things, so you can explicitly set up and control everything on top of it. Okay, so once we will set up the basically the uh, the Vulkan instance, we will actually delve into Vulkan's validation layers and debugging. So Vulkan validations and debugging, well, why we are doing that at the very first beginning? Not even we have rendered a triangle. Now this is very important. Okay, to build a good program, you have to know how to basically debug that program. So setting up validation layers and debugging is the very first thing that you should be doing. So anything you do and it doesn't work, this is where the validation layers help you to catch it. Now what exactly the validation layers? Okay, we will deal into the details, but I can say that Vulkan, it's very smart. If you use some API and use basically give some incorrect basically arguments or basically some enums, okay, it will guide you how you can do correctly. So it will help you to basically ensure that you are basically following the specs as good as possible. Okay, so in other words, it tries to bring some clear diagnostic information for you. All right. Now understanding the GPU interface. Now in this basically particular topic, what we will do is, once we have actually set up the Vulkan API, okay, or Vulkan instance, we have basically a GPU. Okay, now in our CPU there could be basically multiple GPUs. Oh, okay, let's suppose this is GPU 1, GPU 2, this is GPU 3. Okay, so selecting of device says that you can select device 1, you can select device 2, you can select device 3. So Vulkan actually allows you to advertise the devices on your system, and using those you can actually create, or basically you can select a job. You can even select multiple GPUs and you can configure their jobs. Now this is not something which is very much possible in OpenGL, right? We will see it in detail, so this is not a lecture that we will delve into. So the next thing is that once you have, let's suppose actually I choose this device. Okay, let's select green. So the green indicated that I'm doing a basically Vulkan programming, and it advertises me 3 GPUs. I selected GPU 1. Now if I wanted to work with GPU 1, I don't directly work with the physical device, but what I'll do is basically I'll create basically some logical device. Okay, it's a logical, it's still the same device, okay, but we will call it as a logical. We always work with the logical device. You can create as many as logical devices of a physical device, okay, and work with it. In other words, you always work with logical devices in Vulkan programming. Okay, so you select a physical device, but after that the device that you see in your programming, it's all about logical device. Okay, now so one thing which is very important to understand, that a logical device, it's not basically the GPU itself. Okay, so rather I would say that it is basically a software interface to that GPU. Okay, so in our case it's basically the GPU one. Now you can actually think of basically a layer of your application which actually send commands and manage resources. Now all these commands, all these managed resources, they are basically going to deal explicitly with Vulkan using this logical device. And from this logical device, all these command buffers or resource management, it needs to go to somewhere, and that somewhere is basically GPU. But who is going to carry it? Who is going to carry it? It's going, I mean, it's basically the queues. So queue is basically, you can understand, this is basically a queue. Okay, a queue, what it carries is basically it carries command buffers, command buffers, command buffers, command buffers, command buffers, command buffers. Okay, and how it works, basically we record the command buffers. record start and record end. Okay, command C command buffer. So these are command buffers. Okay, and command buffers, they accumulate commands in a sequential way. Okay, so we will see this, but the idea is basically to get a good insight of Vulkan, of this program today, right? So let's see what we will do next. So once we have basically set up the queues, the next thing is basically presenting image to the screen. Okay, if you will see, by lecture, or I mean by third or fourth topic, actually we created basically some window, right? Now once you have created that window, you need to render something into it, and usually it's basically texture, right? We wanted to render some texture, so we called it as basically images. Okay, and when we render those images, the technical jargon in Vulkan that we use is basically presenting images to the screen. Okay, so up until what we did, basically we have set up our system, we understand the GPU, we created a physical device, then we created a logical device, we also created basically a window. Okay, we know basically how the window I mean how the logical GPU, it sends basically command buffers to the from CPU to GPU. Now what we are trying to do is basically using these capabilities. What we wanted to do, we wanted to add some images onto the screen, onto that window. Now for that we basically need some window management or surface management. Okay, so this topic we will deal into detail, but the technical jargon we called it here as swap chain. What is window surface? Window surface is, by default you have a window which is given by the operating system. You have basically a window which is given by the operating system. Okay, now this window has basically some surface. Okay, now this surface is something what now it doesn't have the surface. What it has is basically, I would say, it's a placeholder. You need to create your own surfaces, so we will look into that. So I think that would be very complex at this point of time to help you understand, but I think I'm into a wrong slide, sorry. Yeah, so you can just understand a Vulkan surface is something like a 2D texture. Okay, we create our own 2D textures. Okay, but at this point of time we are not dealing with textures itself, but you can just understand that it is basically a place upon which you can render your output. Okay, so we called it as window surfaces. Okay, and currently we are using GLFW, so the surface management would be done by GLFW. Okay, so but we will create the surface by ourselves. So, and what you need to understand here is basically the double buffering, triple buffering, and that is something we covered in swap chain. Okay, so in swap chain what we do is basically we create basically images, or we create frames. Now those frames are basically presented onto the screen. Okay, now we have not basically only one buffer, but we could be having double buffering, triple buffering, and we don't just render one basically image. So what we will do is, using the double buffering and triple buffering, we have basically some images which are already into queue. Okay, now this is something basically a concept which is very much familiar in OpenGL, but you don't directly manage it. You provide a flag and it works, okay, but here you have to deal with it. So what you will do is basically, the technical word, it's called swap chain. Okay, so what you will do basically, you will create basically multiple surfaces, and what you will do is basically based upon CPU and GPU, uh, when they complete their job, they will actually present their images onto the screen, and you will try to render it onto the next available image, your rendering job. Okay, so, and all this is basically related with smooth rendering, avoid flickering and tearing, all sort of things. So we will look into that. Okay, now when we actually deal with surfaces, images, okay, like I mentioned, these are basically something texture related. So we will also actually try to understand how to work with those images. Okay, we called it as image views. Okay, we don't directly deal with images, but once we created the images, if we wanted to deal with the images, we work with image views. Okay, and this is something what actually we will try to understand, and see how it is basically accessed and interpreted by the rendering pipeline. Okay, in other words, I would say that Vulkan is very much basically flexible in managing the graphics pipeline. So far you can see, we are getting deeper and deeper, and that is a kind of flexibility that modern programmers they need it for games, they need for particular application, for smart cameras. Now you have basically, tiny cameras, right? So you need basically a very lightweight driver that is capable of handling all, sort of, complex operations, without dwelling into a lot of driver overhead. And this is where the Vulkan actually fits very well. Now, once we have done everything with our rendering surface, that means we have set up our swap chain, we have created images, we have created image views. The next thing is basically to get started with the rendering pipeline. So what exactly the rendering pipeline? The rendering pipeline actually deals with the pipeline. Okay, so what we will do, it's basically we will actually create a graphics pipeline. Okay, and we called it as graphics pipeline object. Okay, and what it tries to do, it's basically try to render your pixels on the screen. Okay, a graphics pipeline, we have basically various stages into it, we will see, but overall, I would say that it's basically a programming pipeline. And unlike OpenGL, this programming pipeline, it's very much object oriented, and there are basically a lot of settings into it. Okay, lot of structures that you have to basically deal with it. Okay, so in other words, what it basically pipeline does, it tries to control your vertex that you wanted to basically render. You have to specify how do you want it to render. So when I say how do you want it to render, it's more technically toward the format, because you are sending some data, your CPU needs to send it to GPU, the GPU need to understand, so you need to do some pipeline configurations. Okay, and this is all about the rendering pipeline. And we do have basically various type of pipelines. One is basically the graphics pipeline, the another one is basically compute pipeline. There could be basically more pipelines. Okay, so but what we will deal in the beginners Vulkan, it's basically the graphics pipeline. Okay, maybe in future we can basically deal with compute pipeline. Okay, now the next thing would be basically to understand the rendering loop. Okay, once you have basically set up the rendering pipeline, you have graphics pipeline object setup, the next thing is basically to basically render this graphics pipeline into your render loop. So what we will try to do, we will try to do basically some frame synchronization, because you are trying to render your frame in your rendering pipeline onto the screen. So what you need to do is basically you need to manage the synchronization. So what is synchronization? Why we need to? Well, we are dealing with double buffering, triple buffering. Okay, so we need to actually acquire which surface is right now available to write, so that you don't overwrite it again. So you need basically some synchronization between CPU and GPU. So once the GPU is done with that frame, okay, you can use it for draw. Okay, and this is something what actually we will try to understand. So finally, I mean, we will try to render our very first frame. Okay, and hopefully at this point of time we will use basically a very uh, minimal data or vertices to draw our first triangle perhaps, or try to clear the background with some fixed color or something like that, but hopefully actually we will draw the triangle here. Okay, now this is something what actually it looks like, that by this time we have something rendering on scale. Now going forward, actually we will deal with the GPU. Okay, and we will understand how GPU manages vertex buffers. Okay, so like I mentioned, there are two type of resources, vertex and texture, I mean uh, buffers and textures. Buffers and textures, two type of resources. Yeah, I think buffers and textures. Okay, probably I'm just confusing about the technical word. Okay, but I think it's basically the buffers. Okay, um, but what we will try to do, it's at this point of time we have set up the graphics pipeline. Next thing is basically you need to render the data, and we know that rendering data, it's all about vertex buffer. And when I say all about vertex buffer, a vertex is basically all about vertex position, colors, normal, textures, okay, and whatnot. Well, this is just about vertex. Okay, but vertex need to be loaded somewhere, right? Now this is where actually we will see how to manage the memory in Vulkan. Okay, so that will be basically next important topic, how you can manage your memory. And this is very interesting. This is not something that actually you can see in in OpenGL. Okay, so there we have basically a different type of memories in GPUs. Okay, and depending upon the usage, okay, they may be fast, they may be slow, and there are various way how you can actually control it. Okay, now we will also actually see how to basically send buffers from CPU to GPU. There are multiple ways, but one of the way that actually we will understand is basically how staging buffer works. We will set up the staging buffer and we will do basically a fast transfer. Okay, so in short, what I want, I mean, if you wanted to understand a staging buffer, it tries to create a copy of your buffer on CPU, and then it basically tries to send that buffer into GPU. Okay, so there is basically a CPU visible memory, and then you have basically a GPU local memory. Okay, so we will understand all these concepts, but the idea is basically here is to give you some keywords to have basically some seeding, so that in future these are certain things that actually your programming or your basically interview, they always resonate. Okay, so it's very important for you being a graphics programmer or a graphics student to use, I mean, appropriate jargons that, I mean, resonate towards the kind of work that you do, and perhaps in a context where it is basically related to the modern programming practices. Okay, graphics pipeline. Okay, then finally we will actually look into basically the device memory and host memory. Okay, that is basically a part we will deal with how basically memory, what type, I mean what different type of memories we have in Vulkan. Okay, so we will deal in detail in that. Okay. Okay, now by this time what we will try to do, we have something which is rendering, but we will try to start organizing our code into a more engine like structure. It's not anymore basically a monolithic code. Now you would be having a class for your GPU, you would be having a class for your queues, you would be having a class for your swap chain. Okay, so just now I covered swap chain, so it may be new, but this is something what actually we will try to organize. Uniform buffers, vertex buffer, how to create them. We don't want it to create them vertex buffer again and again and again by redundant and code, because Vulkan is verbose. Okay, you wanted to render a lot of, I mean it needs basically a good amount of code to, I mean basically render a triangle. Okay, but once we write those, we want it to reuse. We don't want it to always basically write a code of creating a buffer. We just wanted to create a class and use it in a most efficient way we want it to use, and keep it scalable. Okay, so what we want is basically a system centric architecture. Okay, now while we will be doing this, we will also basically look at push constant and uniform buffers. Okay, because we are managing those data, so it's very important for us to see how, I mean those can be managed. You have actually understood uniform buffers in OpenGL. In Vulkan also they are the same concept, but I would say push constant is also similar to a uniform buffer, but push constants are considered fast. Okay, so if you have something which is very small like MVP metrics, this is something where you can actually push them. So uniform buffers you can have basically if large data that is changing every frame, you can do. But the idea is we will actually understand what this new concept like push constant is. Okay, now once we have done this, we will actually create something 3D. We will try to understand model view projection. So I'll try to cover it in some with some basics. I will not dwell into how the model view projection metrics would work, but we will try to create a 3D application out of it using that. But not, the idea is not going into 3D into detail. So I understand. I expect that you would be having a good understanding of matrices, and at least what exactly the model view and projection matrices. I will try to give you basically some overview of these MVPs. Okay, and some just basic good practices how you should be doing that. Okay, the idea is basically you wanted to transform your 3D model so that it gets converted into a 2D screen space, and this is all about your MVP pipeline, model view projection metrics. Okay, now using this we will actually do some 3D transformations, and oh no, I mean I mean MVP it's more towards, I mean your 3D to 2D. Okay, then we will actually add some 3D transformation. So we will use more matrices for translation, rotation and scaling, and we will create basically our model or basically our object to revolve or rotate into 3D world, jumping, whatever so it is. Okay, and then we will also basically add some camera controls. Okay, maybe first person view or maybe basically orbital, I do not know, but we will do some basic camera integration into that. So the idea is, I mean you will see, I mean what you are doing in OpenGL, same what you can do in Vulkan, and the idea is that by the time the fundamentals has basically completed, you have basically a very good idea how the OpenGL versus Vulkan works. Okay. Now, all right. So in the next topic, we will actually deal with the resources and textures. So what we will do is basically, so far actually, like I mentioned, there are only two type of resources: buffers and textures. Buffers we have already uh, deal earlier when we are working with vertex buffer, uniforms, push constants. All these are buffers. The textures are basically things that we wanted to paste on top of the models, like okay, some images. So we will understand how to deal with those. So we will see how the shader data handles it. Okay, what are the memory strategies, how textures are layout, okay, what are image and image views. We have covered image and image views in creating the swap chain, but there I will not cover into detail. You will just consider at basically some fixed step that you have to do to get working with the surfaces, so that you can render your output onto the screen. Okay, now here we will also actually understand the basically texture coordinates, UV mapping, okay, how to load those textures, how to use those textures. Okay, so we will deal with basically how to load images from disk, okay, or basically create GPU images. And while we are doing all these things in shaders, one thing that actually I forgot to tell you, that in Vulkan we use shaders. We use shaders not into a source program, but basically we consume it as a binary. Okay, so it is the same GL shading language, but we don't consume it in the form of text data anymore. Okay, you write the text data, but then you will use some Vulkan tools that off compile your source into a intermediate binary. Okay, and this intermediate binary, what it helps you, it helps you to basically save the compilation time on fly. Okay, and you can use this intermediate I mean shader representation to convert into low level basically binary at the fly time. Okay, now finally we will also look at basically VMA, which is Vulkan memory allocator. So what memory allocator does is basically it gives you a good control how the memory can be managed. Okay, so this is basically VMA is a library. So what it tries to does it basically it helps you to control your memory. So since Vulkan is verbose, you don't need to do a lot of memory management. So what you can do, you can use Vulkan memory allocator to manage those memory. So what it tries to help you is basically it tries to simplify how you can provide basically a structured GPU memory. Okay, and use it basically for allocation and resource management. Okay, instead of doing it yourself at a by doing low level allocation. So you need to deal with a lot of things. Okay, okay, now I think this is where actually we are already coming to an end of this program. We have everything which is set up. Now we have textures rendering, we have buffers rendering, but all so far actually we have learned is how Vulkan works, how you can create textures, how you can manage different aspects of your graphics. Okay, whether it is basically uniform buffers, vertex buffers, textures, images, pipelines, frame buffers. Okay, but what you understood is basically basics. But now it's basically a time where you try to create basically your Vulkan into a nice manageable piece of code. And the idea is basically to segregate your application or basically your game from your engine or basically your Vulkan code. Okay, in other words, stop writing Vulkan just to render a triangle. Start changing your Vulkan code towards a framework that is capable of rendering a triangle without making any changes into your framework. So you have two pieces of code. One is basically so you have two pieces of code. So one is basically your Vulkan code, the another one is basically your game code or basically your application code or basically your simulator. Okay, and it's basically using your Vulkan, and this Vulkan it's basically we created as a framework. Okay, now this framework can be even used basically in an editor, and this specialized editor it may actually it's used to create a game, or it may be actually used to create an application, or it may be used to create an simulator. But the fact is that we are not changing our engine. Okay, so we are creating a very simple. Okay, now since this is basically a beginner level program, so we cannot basically deal a lot. Okay, but what we will try to do is basically we will start programming more towards basically a system based thinking. We will create a very simple game objects. Okay, I will show you how you can actually pass your transform, mesh and materials using those game objects. Okay, we will make use of good ECS practices. Okay, and using those entities and component architecture, we will pass our data into our modern graphics rendering engine. So the idea is here is basically I mean basically we will look at basically the separation of consent. I mean I would say that this is one of the most important design principles in software engineering. The idea is basically simple, which is basically to keep different part of your system like rendering, input, debug, extend, okay, into a manageable separate piece of code. Okay, and they are basically working like an independent basically uh, a piece of block, or I would say I mean like a modular approach. Okay, which is easier to maintain, debug and extend. Okay, and that is basically a key that you wanted to understand if you wanted to create a robust and scalable application. All right, so I think this is what it's all about. I mean this program, and perhaps this is what we will try to create. Okay, I think this is wrong. I just copy this last slide from the previous one. I forgot to get, but yeah, this is basically the last slide that we have. The next lecture that we are going to have is this one. Okay, so this one, this one. Okay, and this is basically the last lecture we are going to have, and after this lecture we will jump more towards the setup of Vulkan. And after today's lecture, actually I will also share basically some of the links for CMake, so that before actually we jump into CMake, basically Vulkan, because I will give you the code and then you have to compile it. You can actually learn some of the CMake stuff by your own. I mean CMake is important. I think you should be knowing it. Okay, we have practiced it well, and with that one I think this is basically the complete lecture that we have finished, which is basically the high level learning of our Vulkan fundamentals roadmap. So if you have any questions, I mean you can drop your questions in the um, the channel that we have created, okay, in the into the grid channel. And I will try to give you an update as soon as possible. Okay, my next lecture would also be very much soon, and you can actually go through that. That will actually come along with some material as well. Okay, but this lecture, it's all about the roadmap and basically an induction of this program. So there will be only a video presentation for this one. But end of the day, actually, I would say that now, if you have basically some time, or it's basically a break for you, it's a very good time for you to just go through this one and learn these basically important aspects of modern graphics programming. I mean, it's truly vital in this fast paced moving world that you should learn these. I mean, in my opinion, I mean, it's not compromisable. Okay, being a computer graphics programmer, these are some of the things that you should be knowing. Okay, now the idea here is basically not to give you a stress, but the thing is that to help and share these jargons with you. I think people learn when they actually listen to jargons, they try to explore. So end of the day, I mean, I would say that my idea is basically to create an interest in my students, in my junior developers, in my friends, okay, to help them basically create an interest. Okay, so currently I'm covering Vulkan. Okay, in future there may be more GPU APIs, there would be more application related skills, but the idea here is that it's a skill oriented program. So I'll be taking 10, 15, 12, I do not know how many lectures, but we will cover this, we will finish this, then we will try to focus on something next. Perhaps you wanted to look at some modern graphics, web APIs for 3D graphics, not OpenGL but web GPU. Okay, probably next that we can do that, or we can do Android or some cross platforming programming, networking. But the idea is that once we completed something, we will start with some new skills. Okay, and currently the level that we are covering, it's beginner. Okay, what I feel is that beginner, it's good enough level if you have basically a good fundamentals. And like I mentioned, uh, my approach, my strategy, or my takeaway is basically I wanted to create an interest. If I am successful in creating an interest, I think you can go for the intermediate and advanced level. Okay, but if not, if you like this, maybe you wanted to go for intermediate, okay, just let me know once this program is completed, so we can actually do an intermediate course on Vulkan development. We will actually create a game engine or an application engine or a framework, okay, that can be actually used to create an editor, and that can be further used to create applications or dedicated applications. All right, so I think with this one, I think I'll try to conclude my today's lecture, and I will see you in the next lecture. Thank you. See you.